Layers are not laid by flood as claimed. Wouldn't wind alone blow them away before they have time to form? Okay, if layers are not laid by a flood, wouldn't wind blow them away? You've got a couple of issues with this idea of wind blowing them away. You're on the right track, but you've got a couple of issues with the wind blowing them away. First thing is, if you go to the many layers, what you find is that there is overwhelming evidence that wind had nothing to do with it, right? It was water, just like we were talking about a minute ago. So the fact that you find entire trees buried next to fish, dinosaurs buried next to marine reptiles, and so on and so forth, you have a lot of what you could call ecological evidence, paleoecological evidence of mixed environments indicating that these were buried underneath a flooding environment. In other words, it was a global flood that buried them. The other issue with wind is it's not just the fossil evidence. You can also go down to the sort of the sedimentological level. You can have a look at the sediments that are there. You are dealing with an area or an environment, a bunch of sediments, and I'll let Glenn, I'll let Glenn mention a bit more about this. You've got an area which is devoid of things like oxygen, which you would find a lot of if, of course, wind had transported the currents. Now, if you come with me to the south coast in England, down near Bristol, right, you've got these lovely red sandstone cliffs where it says this was a desert that was laid down by a flood, that was then covered over by a flood. Okay, so you have a desert that's overwhelmed by a flood, but if you look in the desert rocks, what you realize is that all the pebbles have been rounded by water, which doesn't sound much like a desert. In fact, you have huge volumes of gypsum crystal in there, which requires a moist and wet environment to actually be produced and crystallized. So there is an issue with the argument of wind. You do have a lot of evidence that it's actually water that's depositing it. However, the sort of point that you're getting at, which is an erosional point, is a really important one. You need to have a rate of deposition, a rate of formation that is faster than your rates of erosion. Now, if you go to, say, a chalk cliff, right, your cliff formation varies, but you can easily work it out by taking the supposed amount of time it took to lay the chalk down and dividing it by the height, and you get rates like at Hunstanton, it's about 0.002 millimeters per year. Now, this is laid down in an underwater shallow sea environment, right? At a rate of 0.002 millimeters per year, your rate of erosion would be far, far, far higher than 0.002 millimeters, and so you end up with a deposit that never forms in the first place. So your biggest issue with the time, that's the millions of years, right, is actually trying to explain how you had enough of a process to actually lay down the deposits without them getting eroded and without them getting destroyed. So that's your key issue, right? It's this issue of erosion. You need it to be quicker than, you need your deposition rather to be quicker than your erosion, and you can't get that with millions of years.
Well, yes, you need an oxygen depleted environment to stop the microbial process. But even after the oxygen is gone, microbes can continue for quite a while. So these creatures have to be buried very rapidly in an anoxic environment, which is a flood type of environment. And wind deposits going to be oxygen rich. Now, we do get creatures buried in sandstorms. That's quite obvious, but we're not getting fossils made from them. So, yeah, you're talking about a water deposition, a fast, deep water deposition.
Yeah. And you need a glue to glue things together as well,
Yes.
and wind doesn't provide a glue.
Yes.
Basically.
I was just going to say the whole idea of this constant deposition is not something really we observe. Maybe in certain parts of estuaries or wherever we might see, layers coming in, but we don't see this. I mean, even Charles Darwin sees the problem in his theory for a long time. So he talks about periods of deposition and periods of erosion, and tries to use that to explain why there's vast periods of time that are not represented because they were periods of erosion. But I guess it boils down to the fact that we've never witnessed vast periods of deposition anyway.
Or mass fossilization, like we see in the fossil record.